Okay, question 5. In the diagram below, O is the center of the circle and point T lies on chord RS. Prove the theorem which states that if OT is perpendicular to RTS, then RT is equal to TS. Okay, right. So we can start off by constructing these radii from the center to S and then from the center to R. So we can construct OR and OS. Okay. Now in triangle OTR and triangle OTS. Okay, so we're gonna prove congruency. We're gonna prove that OTR is congruent to OTS, and if they are congruent to each other, that means that RT is equal to TS. Okay, so we can start off by OR is equal to OS. So that's our first one. OR is equal to OS. Why? Both are radii. 2. OT is common. And then 3. T2 will equal T1, which is 90. Why? Because of angles on a straight line. Yeah. So that would be okay. Right angle hypotenuse side. Right angle hypotenuse side. So we've shown that triangle QTR is in fact congruent to triangle, not Q, sorry, OTR. OTR and OTS are congruent. Why? Because of right angle hypotenuse side, and therefore RT is equal to TS. Okay. Next one. Okay, so they say in the diagram, O is the center of circle ABD if is a point on AB such that DOF is perpendicular to AB. AB is equal to FD is equal to 8. AB is equal to FD, which is equal to 8, and OF is equal to X. Okay. Right. So if AB is equal to 8, that would mean that FB is equal to 4, because line from the center perpendicular to a chord would bisect that chord. So if AB is 8, that would mean FB is 4. Now, so that would be 4 units. And we know that if D is also 8, which would make OD 8, take away X, so that would be 8 minus X. Okay. Okay, so let's write that. So if b is equal to 4, okay, yeah. So now because OD is 8 minus x, OB would also be 8 minus x. Why? Because OD is a radius as well as OB. So OD is the same as OB, which is 8 minus x, because both are radii. Okay, so now if I look at this triangle over here, sorry, and the instruction, we didn't even get to the instruction. The instruction is determine the length of the radius of the circle. Yeah? So we need to determine what x is. Once we know what x is, we can determine what the length of the radius is. So now, because in this right angle triangle I've got terms for each side, I can do the theorem of Pythagoras. Okay, let me try and do it in here. So that's going to be 4 squared plus 8 squared is equal to 8 minus x squared. So that's 16 plus x squared. That's going to be 64 minus 16x plus x squared. Okay, the x squares, if I take that over, it will cancel with that one. So I'm left with just the constants and the term of the x. So what I'm going to do, I'm going to bring over the negative 16x, that will become positive. And then I've got 64 minus 16. So that is how much? 58, 48. And then 48 over 16, that's equal to 3. So therefore, the radius would be, so the expression for the radius was 8 minus x, so therefore it's 8 minus 3, and that is equal to 5 units. Okay.